Hello learners, I am Dr. Subodh Kisharwani, working with Indira Gandhi National Open University in School of Management Studies. The topic which I am going to talk today is probability rule. Prior to going into the depth of this topic, I just want to throw a light that this is, part of our program called MCOM, and this is a course called MCU3, Research Methodology and Statistical Analysis. We are in the fourth block, which more focused on, the testing, or rather we can say the testing of probability testing or the hypothesis testing. And we have two important sessions, which is, just giving the glimpse about what exactly the probability is. And then we are talking more about, the approach to probability, and now we are talking about the probability rules. So when you talk about the assumptions, when you talk about the statistics, when you talk about the sampling, I think probability is something which is a need of an hour, and it's very important, the component as far as, the assumption is concerned, as far as the estimation is concerned, because, the whole statistics revolves around the sample, and the sample used to come out from the population. So there is a population, there is a tested population, and there is a sample. So sample is a very small portion of the cake from the big bunch of that, and you are just taking the small portion and evaluating that particular portion, and then come to the conclusion that what could be the trend of the whole population is. So you are taking a small portion and knowing about the big portion. So for that reason, the probability is going to play a very important role, and it's quite important because accuracy and this estimation is one of the important ingredients as far as the probability is concerned. So this probability rule is something which is quite in numbers. It's in 10 numbers, and we are going to talk more about the probability rules, and then we will switch over into some good examples which can defend our the ruling philosophy. So if you talk about the first probability rules, I think the probability of an event A is number between 0 and 1, and it can be expressed by the equation called 0 is less than or equal to PA, less than or equal to 1. So this is the rule number 1. If you talk about the probability rules, the rule number 2 is the sum of the probabilities of all basic outcomes in the sample space must equal 1. So the formula is PS equals to P E1 in brackets plus PE2 plus PE3 and so on up to the n number. So and this value is equals to 1. So this is the probability rule number 2. And if you talk about probability rules number 3, I think the rule 3 is much focusing on the probability of the union of two basic outcomes is equal to the sum of the probabilities of the individual events. And if we talk about the equation, the E1 equals to in brackets E1, E2, E3 is a number, and if you talk about the equation that PE1 equals to PE1 plus PE2 plus PE3, that is probability of capital E1 equals to probability of this small e1 plus probability of small e2 plus probability of small e3. So now in the same manner we have got the rule number 4. The complement of an event is the remainder of the sample space beyond the event, and PA is noted by 1 minus PA. So PA union B is equal to probability of A plus probability of B minus probability of A and B, so which is read as A union B. So if you talk about probability rules, the addition rules describe the probability for the union of two events as the sum of marginal probabilities minus their joint common probability. So PA or PB equals to probability of A, probability of B minus probability of A and B. So this is the formula by which we are going to do it. And if you talk about the probability rule 6, additional rule for mutual exclusive events A and B, where probability of A union B equals to probability of A plus probability of B, or PA or B is notified as probability of A plus probability of B. So PA by B is equals to PA by B upon probability of P. So probability rules, this is called probability rule number 7, and conditional probability for any two events A and B is this. So where we have seen that this PB is not equal to 0. So probability rules, if you are talking about probability rules 8, conditional probability for independent events A and B is probability of A by B equals to probability of A, and probability B by A equals to probability of B. So this probability rule 9 is more talking about multiplication rule of two events. A and B is probability A and B equals to probability of A multiplied by probability of B by A, or probability B by A equals to probability of B multiplied by probability of A by B. So this is the different rules which are there. And if you talk more about the rule number 10, which focus more on multiplication rule for independent events, where A and B is denoted by P A and B equals to probability of A multiplied by probability of B. So now what we have observed that these are the rules which are very important ingredient, and on the other hand there are certain conditional probability and the multiplication rules which we have already talked about. So conditional probability is the probability of an event occurring given that another event has already occurred, and probability B by A is equal to probability of B given A. So for example, if we are going to take one example, there are 5 red chips, 4 blue chips and 6 white chips in a basket. 2 chips are randomly selected, and what we have to do, we have to find the probability that second chip is red given that the first chip is blue, and assuming that the first chip is not replaced. So because the first chip is selected and not replaced, there are only 14 chips remaining, and as far as the selecting of a red chip is concerned with respect to first chip is blue, the answer is 5 by 14, which comes to 0.357. So conditional probability, there are some more examples of the conditional probability. 100 college students were surveyed and asked how many hours a week they spend studying. The results are in the table below, and find the probability that a student spends more than 10 hours studying given that the student is a male. So if you see this particular the table, you will find out that what we had done first, we have make a table of separate table of male and female. The male who have scored less than 5 are 11, the male who have scored between 5 to 10 are 22, and male who have scored more than 10 are 16. In the same manner, we have calculated about the female, and with respect to that you find out less than 5 is 13, 5 to 10 is 24, and more than 10 is 14. So the total comes to, for male is 49 and the total comes for female is 51, and it is equalizing the total of 100. So now what we have to do, we have to find out the probability that student spends more than 10 hours studying given that the student is female. So the sample space consists of 49 male students. Of these 49, 16 spends more than 10 hours a week studying. So what we have, if you talk about the probability that a student spends more than 10 hours studying given that the student is male, we have taken 16 divided by 49, which comes to 0.327. So this is called conditional probability, where we have put the condition that more than 10 is going to be considered and the male is considered. So there are two conditions which are there, so that is the reason it is going to be called the conditional probability. So independent events, so two events are independent if the occurrence of one of the event does not affect the probability of the other event. Two events A and B are independent if probability of B with B by A is equal to probability of B, or PA by B equals to PA. So events that are not independent are dependent, and if you take an example, I think decide if the events are independent or dependent. Selecting a diamond from a standard deck of cards A, putting it back in the deck, and then selecting a spade from the deck B. So what we have observed that 13 by 52 is there, and 1 by 4 is the answer, and if you talk about B, 13 by 52 we have taken and 1 by 4 is the answer. So the occurrence of A does not affect the probability of B, so the events are independent. And if you talk about the multiplication rule, I think the probability that two events A and B will occur in sequence is probability of A and B, where probability A is going to be multiplied by probability B by A. If events A and B are independent, then the rule can be simplified to PA and B equals to PA multiplied by PB. So two cards are selected without replacement from a deck. Find the probability selecting a diamond and then selecting a spade. So because the card is not replaced, the events are dependent, and P diamond and spade equals to P diamond multiplied by P spade by diamond. So 13 by 52 multiplied by 13 by 51 equals to 169 divided by 2652, and that comes to 0.064, which is the probability of diamond and spade with an rule of multiplication. So a die is rolled and two coins are tossed. Find the probability of rolling a 5 and flipping 2 tails, and p rolling a 5 is equal to 1 by 6. Whether or not the roll is 5, p tail equals to 1 by 2. So the events are independent. So now p5 and t is equal to p5 probability of 5, probability of tail, and probability of tail. So this is the manner by which we are going to do 1 by 6 is to 1 by 2, 1 by 2, and answer comes to 1 by 24, which equals to 0.042. So what we have observed that the addition rules, two events A and B are mutually exclusive if they cannot occur at the same time, and A and B are mutually exclusive, what we have seen, and A and B are not mutually exclusive. So decide if the two events are mutually exclusive: a roll number less than 3 on a die, event B roll a 4 on a die. So if you see, this is the manner by which the things are going to be done, and these events cannot happen at the same time, so the events are mutually exclusive. Decide if the two events are mutually exclusive. Event A, select a jack from a deck of cards, and event A, this is event A, and if you talk about event B, select a heart from a deck of cards. So what we have seen that as far as A is concerned, we have to select a jack from a deck of cards, and as far as B is concerned, we have to select a heart from a deck of cards. So now we have put the circle in which A is more talking about select a jack from a deck of cards, and B is more talking about select a heart from a deck of cards. Now because the card can be jack and heart at the same time, the events are not mutually exclusive, and we have seen that this area is the overlapping area. So the probability that event A or B occur is given by P A or B, or P A plus P B minus P A and B. And if events A and B are mutually exclusive, then the rule can be simplified to P A or B equals to probability of A plus probability of B. And for example, if you roll a die, find the probability that you roll a number less than 3 or a 4, the events are mutually exclusive, and probability of roll number less than 3 or roll as a 4, then probability of number is less than 3 plus probability of 4, which comes to 2 by 6 plus 1 by 6 equals to 3 by 6, and it is now coming 0.5. So what we have observed that the additional rule is somewhat the rule which is more focusing on the additional aspects. So if you take one more example, I think it can clear us and give the clear view about that. A card is randomly selected from a deck of cards, and we have to find the probability that the card is a jack or the card is a heart. The events are not mutually exclusive because the jack of hearts can occur in both the events, and as far as probability to select a jack or select a heart, we have to see that probability of jack plus probability of heart deducted by the probability of jack of hearts, and the value is 4 by 52 plus 13 by 52, and we are going to deduct 1 by 52, and the answer is 16 by 52, which comes to 0.308. So these are the additional rules which are there, and the example which we have taken in a different, the same the illustrations we are taking. 100 college students were surveyed and asked how many hours a week they spend studying. The results are in the table below. We have to find the probability that a student spends between 5 and 10 hours or more than 10 hours studying. So what we have done in the beginning stage, that the way we have done in the previous rules, we have plot the table. Male with less than 5 is 11, male with 5 to 10 is 22, more than 10 is 16, and total is 49. Female with less than 5 is 13, 5 to 10 is 24, more than 10 is 14, total comes to 51. So now what we have done, we have first draw the table, and the events are mutually exclusive. Probability of 5 to 10 hours or more than 10 hours equals to 5 to 10 plus probability of 10, and 46 by 100 plus 30 by 100, which comes to 76 by 100, and answer is 0.76. So what I mean to say, this additional rule of probability, if two events A and B are mutually exclusive, then otherwise probability of A union B equals to probability of A plus probability of B, and probability of A or B equals to probability of A plus probability of B minus probability of A and B. And this is the best way to pictorially explain that: probability of A plus probability of B, and we are going to deduct probability of A and B, and the value comes in this way, which is called a probability of A or B. So what we have observed that this is the manner by which we have selected. Now there are fundamentals of counting principles. If one event can occur in m ways and second event can occur in n ways, the number of ways the two events can occur in sequence is m multiplied by n, and this rule can be extended for any number of events occurrence in a sequence. So if we take an example, a meal consists of main dish, a side dish and a dessert. How many different meals can be selected if there are 4 main dishes, 2 side dishes and 5 desserts available? So this is the manner by which we have done it, of dishes, of side dishes and of desserts. So there are 40 meals available, and this is the answer. So fundamental counting principle is that two coins are, if we take one more example, 2 coins are flipped, how many different outcomes are there, list the sample space. So if you see the first coin, when it could be tossed, the possibility is that either it could be heads or tail. So 2 ways to flip the coin, and if you if the second coin is tossed, there is a possibility that head is there and heads and tail is there for the first coin, and for the second coin it is tails and head. And tails, if you are talking about heads and tails. So 2 ways to flip the coin, there are 2 into 2, 4 different outcomes, that is head head, head tail, tail head and tail tail. So this is the manner by which we have calculated, and the fundamental counting principle is that the access code to if we take one more example, I think the access code to a house security system consists of 5 digits. Each digit can be 0 through 9. How many different codes are available if each digit can be repeated? Each digit can only be used once and not repeated. If we take the answer, because each digit can be repeated, there are 10 choices for each of the 5 digits. 10 is to 10 is to 10 is to 10 5 times, and it comes to 1 lakh codes. Now because each digit cannot be repeated, there are 10 choices for the first digit, 9 choices left for the second digit, 8 for the third, 7 for the fourth and 6 for the fifth. So answer is 10 is to 9 is to 8 is to 7 is to 6, which comes to 30,240 codes. So anyway, I think this is the rule of probability, and we have some more thought-provoking sessions which talk more about the probability rules, because the probability is, as we have already talked about, it's based on the assumption, and since accuracy and this estimation is playing a very important role into it. So this rule and approach is quite important. We have a very elaborative session which talking more about the rules and more talking about the approaches, and as far as the concept building is concerned with respect to the probability is there, we have a very dedicated session which talks about that. So in a coming session we are going towards more advanced features of probability, rather than talking about the probability distribution using the mathematical analysis to know more about the probability. So thank you very much. We will have some more thought-provoking sessions in coming days. Thank you very much.